Hello, everybody, and thank you for joining us today. My name is Jake Stakowitz, and I'm excited to be here today giving this webinar with Golden Software. Today, I'll talk about how to bring your data to life with both Google Earth and Surfer. The first half of this webinar, we will cover importing Google Earth data for use within Surfer. This will include how to import and georeference an aerial image from Google Earth into Surfer, how to transform KML data in Google Earth so it is grid ready for Surfer, and how to overlay multiple map types onto our aerial image in Surfer. The second half of this webinar, we will focus on exporting maps created entirely in Surfer to Google Earth. During this section, I'll go over exporting your Surfer project to Google Earth as a KML KMZ file, and then how to display those files in Google Earth. There'll be a few stopping points during the webinar where I take a couple minutes to answer any questions. You can send your questions to the webinar host via the Q&A located on the Zoom toolbar at any time. Type in your question, it'll be sent to the webinar host who will either answer it or forward it to me. And please use the Q&A function rather than the chat. This will allow the host to ensure we see all questions in a timely manner. Feel free to send in all your questions, and if we don't have time to answer them during the webinar, we'll answer them via email once the webinar is complete. Finally, this webinar is being recorded, and later this week, we will post the recording along with the data used in the webinar. And we'll send each of you a link when that's posted so you guys can test these examples out yourself. So let's get started. First, we're going to discuss exporting imagery out of Google Earth and importing it to Surfer. Surfer has the ability to download base maps directly from a server using the new map base from server command. But you can also use Google Earth if you enjoy how it displays aerial imagery, such as these 3D buildings or these roads. For this map that we're going to be creating, our client prefers the way Google Earth labels and color codes roads. So we're going to grab our aerial imagery from Google Earth directly. I already have the location that our client wants to use open up here. A quick tip when you're working in Google Earth, if you press R on the keyboard, you'll get an exact overhead view of your imagery. And now to export this view, I'm going to click File, Save Image. And that's going to open up some options that we can adjust. First off, I'm going to bump the resolution up to 1080p so we have a nice clear picture when we bring it over to Surfer. Then I'm going to click on the map options drop down here, and I'm going to turn off all these extra elements. I feel like they kind of just add clutter, but I will leave the compass on. I like this north arrow down here in the bottom. Then you can click on the map to close that menu. Then we can click Save Image. And this is going to bring up the save window, and I'm going to go ahead and call this our aerial imagery. And I'll save it as a JPEG, which is the default. Once that's saved, we can go back to Surfer, and we can import our new aerial image JPEG as a base map. To do so, I'm going to click from the Home tab, New Map, Base, click Base, and then choose our aerial imagery JPEG. I'm going to go ahead and zoom into that by pressing Control L. And now that we have our base imagery map open, we can see that these axes aren't actually using real world coordinates. These numbers are actually the pixel values of that JPEG image. But we can assign these real world coordinates by using the georeferencing feature in Surfer. To do this, we'll select our base layer in the contents window. And then we're going to go down to General in the Properties and click Georeference Image. This is going to open up our georeferencing window. And when georeferencing, Surfer needs at least 3 points, but using 4 will provide better results. Additionally, it's best to ensure these points are evenly distributed throughout the image. If you know the coordinates of the corners of your image, you can use the Add Corner Points button. Our corners are pretty arbitrary though, so instead what we're going to do is use the Add Mode tool, and we're going to use these evenly spaced out intersections around this park. Now, I don't know the latitude and longitude coordinates of these intersections offhand, but we can easily get that from Google Earth. So I'm going to go ahead and open our aerial image back up in Google Earth. And to find our coordinates, we can use the Add Placemark tool, which is this yellow push pin up here at the top. If you click the Add Placemark option, then we can drag this push pin to our area of interest. I'm going to go ahead and zoom in so we get as close as possible, and then drop that there. And now you can see that Google Earth is giving us the exact latitude and longitude of that intersection. I'm going to go ahead and name this 1 because I know we're going to do this 4 times. I'm going to copy the latitude here, then go back into Surfer, and I'm going to use the Add Mode tool, zoom into the same intersection, and go ahead and click and paste that latitude into our target Y. Now the source Y and source X are those pixel values that I was talking about earlier, and the target Y and target X are the coordinates that we want to replace those pixels. So I'm going to hop back into Google Earth, grab our longitude, copy that over. And like I said, we want to do this 4 times for the best results. So I'm going to go ahead and speed through that process here. Click Add Mode, click in the intersection, hop back over to Google Earth, click Add Placemark, drag our pin to the same area, title this 2, and copy over our coordinates. Now when you're copying over the coordinates, make sure you don't grab this colon here on the end. That's going to be a symbol that Surfer won't recognize if you try and use it in your coordinates, and you'll cause an error. So let's scroll down here to our 3rd intersection. Add the point. Do the same in Google Earth. Call it 3. For our last one now, click Add Mode, and add a place mark. All right, and while I was entering those in, you may have noticed this error column here. If you have a higher number in your error column, it indicates that whatever points you're using to georeference aren't quite accurate. I can demonstrate that real quick if I just took out this negative sign, and then I click on my map. You can see our error number skyrockets up, and that's because that doesn't make any sense that this coordinate would be halfway across the world from all the other ones. We can fix that just by adding that negative sign back in and clicking on our map. So once we're satisfied with the accuracy of our points and error numbers, we can click Update Map, click Yes, and click OK. And we can close out of our georeferencing window. And now you can see we have some real world latitude and longitude coordinates here. Also, now that our map is georeferenced, we can go ahead and set the coordinate system for our layer by making sure we have the base layer selected, then going to the coordinate system in the Properties tab, clicking Set. And then I know that I want to use World Geodetic System 1984, so I'm going to go ahead and start typing that in the Search tab. That's okay. And lastly, if I zoom out a little bit, you can see that this is kind of a small map. So I kind of want to bump up the scale here. So I'm going to click on our map in the contents window, then click Scale in the Properties. And down on our Y scale, I'm going to bump this up to 4.6 instead of 2.6. And now we have some nice aerial imagery with real world coordinates that we can start building onto. Before we get started into adding more layers to this map, I'm going to take a few minutes to answer any questions that have come up so far. All right, I see when you get, so the question is, when placing the Google Earth coordinates, do you put the square box around the pin or the bottom of the pin to the point of interest? So let me open up Google Earth. Press OK. And I'll just add a new pin for the sake of. So when I do it, I add the bottom of the pin. It is really a millidecimal of a difference. And it really shouldn't have such a dramatic effect if you use the bottom of the pin, but if you use the bottom of the box instead of the pin, but I do use the bottom of the pin. Okay, when georeferencing, do you always aim for 0 error in the fit? If you are really confident with the accuracy of your points, like if you were doing this method, I would aim for 0 because, I mean, it's telling us the exact coordinates. But if somebody gave you a coordinate set that you're georeferencing with, as long as it's a pretty low error number, you should be fine. All right, and now that we have our aerial image georeferenced, our client is interested in trying to display a contour map on top of this park area here of our image. Unfortunately, they don't quite have the data on hand to create a grid file for this layer, but we can actually pull the required data for a grid out of Google Earth as well. So first, let's open Google Earth back up to that image we've been using the whole time. I'm going to zoom out and I'm going to turn off all these pins just so they don't distract us. And if you'll remember what I said earlier, if you press R on your keyboard, it gives you that nice exact overhead view that we're looking for. And so, like I mentioned, our client's interested in creating a contour map of this park area right here. So we can go ahead and highlight this area of interest by using the ruler tool up here on the scale bar. When I click on that, it opens up this ruler dialog, and I'm going to select circle since that most closely matches the shape of this park. And then if I click right in the middle of the circle and drag out, then click, now I've drawn a boundary around our park. And if I press save, it'll go ahead and add it to the map. And I'm going to leave the name as circle measure. That works well for me. And now that we have this boundary highlighting our area of interest, I'm going to go ahead and select add path, which is up here next to the add placemark pin we were using earlier. And the add path tool lets me draw a path through my area of interest. And what each of these red dots represent is actually the latitude and longitude coordinates of that exact area. So if I just scribble to my heart's desire here, I am actually creating hundreds of latitude and longitude coordinates that I can use as data points for creating an XYZ grid in Surfer. So I'm going to go ahead and scribble away here. It's not really a right or wrong amount of coordinates you get, just an amount that you're confident enough in the grid you're going to be creating. And it's okay if you go outside of the lines as well. And I feel pretty good about this. So I'm going to go ahead and call this our park data. Then I'm going to press OK. And now you'll see that I've added that park data path to our places window over here. Now I want to just export our park data. So I'm going to turn off our circle measure and make sure I have our park data selected. Then I'm going to go to File, Save, Save Place As, and we're going to save this as a KMZ. I like the name Park Data, and I'm going to keep that down the line, so I'm not going to change the name. Then if I press Save, we can now start taking the steps to turn that path into a grid. but Surfer doesn't directly support creating a grid from KMZ files. So there's one more step that we need to take, and that is to convert the KMZ file to a TXT file using a third-party website with a free online converter. Specifically, I'm going to recommend using this website called GPS Visualizer. GPS Visualizer is a great tool because it has the option to add elevation data to our coordinates using NASA satellite databases as reference. That elevation data will then give us our needed Z coordinates when we go to create our grid for our contour map. So I'm going to upload our park data KMZ file right here where it says choose files. And then once that's uploaded, I want to confirm that our output format is set to plain text, which will create a TXT file. And then the most important part of this conversion is this add DEM elevation data. If we choose this dropdown here, we can see all the different databases that GPS Visualizer will pull from to add our elevation coordinates. I'm going to go ahead and choose best available source so that GPS Visualizer will cross-reference all of its databases and choose the most accurate source for us. Once that's done, you can go ahead and click convert, but for the purposes of this webinar, I have already done that data conversion so that we can save a little bit of download time. So since we already have our park data TXT file, let's go back into Surfer and let's go ahead and open that up as a sheet by clicking File, Open in Worksheet, choosing our park data TXT. Press OK to the import options. And now you can see we have a pretty extensive database, which is all those hundreds of red points from our path from earlier. And we can confirm that these points are accurate because they are basically, they're very similar to the same ones that we use to georeference our aerial imagery. GPS Visualizer also adds a couple extra columns that we can just go ahead and delete here. So I'm going to do that. And then I'm going to save this file as a DAT for gridding. So I'm going to use File, Save As. Then I'm going to save it as a DAT and just press save. Press OK on the export options. Now let's go back to our aerial imagery. And up on the top ribbon, I'm going to click Grids, Grid Data. And from the Browse window, I'm going to choose our Park Data DAT. And then I'm going to leave our gridding method as crigging. That's what I would recommend. And then we need to set our variables for our X, Y, and Z. So for X, let's go ahead and set that as longitude. Then for Y, we can leave that as latitude. And Z, let's go ahead and set that as altitude. Once those are set, we can go ahead and skip to the end so that we can choose our output options. And I'm not going to change any of these because I'm happy with how they are, but I do want to change that we add this grid as a layer to our already existing map and as a contour layer. If we were interested in the grid report and grid statistics, I could also check that box here. For our purposes, we won't really be needing it though. Press finish, press OK. And now you can see that we have overlaid a contour layer and we didn't have to go out to this park and directly collect that elevation data ourselves. We were able to just pull that out of Google Earth and convert it. And now that our contour map of the park has been overlaid, we can see that because Surfer creates grids in a rectangle by default, these contours go a little bit past our park boundary that we want to highlight, and we could probably clean this up, make it a little bit neater. And so to clean this up, we can assign no data to the areas outside of the park boundary that we don't want contours displayed for. To assign our no data area, first we're going to select our map in the contents window. Then we are going to go to Home, Add to Map, Add Layer, and add an empty base layer. Once our base vector layer is added, I'm going to select it in the contents window. And then I'm going to go to features up here in the top ribbon, and then insert, and I'm going to choose ellipse, since that's most closely what I would describe this boundary for. And I'm going to draw an ellipse around our park boundary. I'll know that I'm ready to draw because my arrow is turned into these crosshairs. It may take a couple of tries to get it perfect, but let's see how this goes. All right, and I'm pretty satisfied with that right on our first try. So I'll go ahead and drop that. Then I can press escape to get my arrow back. And now that we have our boundary set, I am going to go to grids, assign no data. Then for our input grid, from the drop-down menu, I'm going to select our contours park data grid that we just created. And for our no data polygon boundary, I'm going to choose the base vector layer that we just created with our ellipse inside of it. Then I'm going to go ahead and select no data outside, and because that's going to assign no data outside of our ellipse. I'm going to go ahead and name this our contours park boundary. And we are going to add this grid directly to our map again. And we're going to add it as a contour layer. So I'm going to press OK. Okay. And then I can go ahead and turn off that ellipse we drew and our original contours layer. And voila, now we have a nice contour layer fit into our park boundary on top of our georeferenced aerial image. All right, and that's going to finish up the portion of the webinar that relates to bringing Google Earth data into Surfer and manipulating it. I'll take a few more questions now before we get to the last topic of this webinar, which is bringing Surfer data into Google Earth. All right, so I see a question, can we convert this to UTMs? Yes, we can convert it to UTMs. You could go up to the map and change the target coordinate system here. So long as all of our layers also are in the same coordinate system, if we change the target coordinate system of the map, it will convert it to UTMs. And then when working in Google Earth, if we go up to Tools, Options, we can set it to UTM, which is this Universal Transverse Mercator. But when you bring it out of Google Earth, it's always going to be in latitude and longitude no matter what. That's just the only coordinate system KMLs work with. All right, I see another question. Will this work in Africa? And yeah, you could use this exact same workflow with any area as long as Google Earth has the latitude and longitude of that area. You could duplicate this workflow literally anywhere. And lastly, will we be providing a cheat sheet? Yes, we will be sending the recording of this webinar along with all of the data that I used for this webinar to anybody who signed up for it. All right. Well, now let's get into talking about how to export a map from Surfer to Google Earth. For this example, I'm going to be using one of our sample maps, which is a peaks and depressions map of Crater Lake in Oregon. We're going to use this map to demonstrate how the varying export options affect the export file when it's brought into Google Earth. First, before we even start exporting, I'm going to hide all of my axes in the contents window. I'm doing that because I know when exporting, Surfer grabs all visible objects, and I don't really need those axes showing up when we bring this into Google Earth. And for that same reason, I'm also going to hide this silver color relief layer because I really want our peaks and depressions areas to stand out when we add them to Google Earth. Now we can go ahead and get started exporting by going File, Export. And I'm going to go ahead and name this Crater Lake PD, which will stand for Crater Lakes, Peaks and Depressions. And then I will save this as a KML file. We could also save it as a KMZ if we wanted, but a KMZ file is just a compressed version of KML files. So they are very similar and the export options are the same. Then when I go ahead and click Save, we can get into our export options dialog. I'll go ahead and move that out of the way so we can see our map while I talk about it. And the export options dialog is where we tell Surfer how to export those labels, lines, and points we have. First, we have the scaling page. The most important thing here is to verify that your scaling source is in map units and not page units. You can choose your scaling source from the drop-down menu here. And despite the fact that I turned the color relief layer off for exporting, we still want to use that as my scaling source because it is set to WGS 1984, which uses latitude and longitude, which Google Earth recognizes. Next, we have spatial references. If your map does not have a coordinate system defined for it, you will not have the spatial references page. So if you don't see this page, that's fine. And if you do see it, you really don't need to select anything extra here unless you know you're working in a different program that requires a special reference file type. The last page is the KMZ Options page. This is where you define how Surfer exports text, symbols, polylines, and polygons. Each of the selections for these options can be great in their own way. It just depends on what you are exporting and how you want it to look. I'll go ahead and walk through some of these options to give you an idea of what they do. And if a user is going to change the export options, it is usually one of these first two options, the text objects and marker objects. The rest of these options are usually left to the defaults. The first option is for text objects. This is how Surfer will export the text to the KML or KMZ file. And that includes things such as the contour line labels, axis labels, and any sort of text you have on your map. There are 4 options to choose from. The first one is export as Placemark Pins with text descriptions. For this option, each text item is exported as a placemark with a text label. When you open it in Google Earth, each text location has a little icon at the location, which is usually that yellow push pin by default. And then the pin itself is labeled with the text. For the second option, we have export as rendered curves and areas. This option converts the text objects to polylines and polygons so that the text looks just like it does in Surfer. For example, if you had rotated labels on your map, the text will appear rotated in Google Earth as well. Google Earth does not support text rotation, so this is the only way to export rotated text from Surfer and have it show as rotated in Google Earth. This becomes a poor option if you have tons of text labels because each character will be its own polyline and polygon, and you could potentially have thousands of polylines and polygons in your KML or KMZ file, which would significantly increase your file size. Third, we have export as labels. These are placemarks with a text descriptor as well, only there's no icon, so you only see the text labels. This is pretty nice if you have a lot of text on your map, and the text size will also scale and get bigger or smaller as you zoom in and out in Google Earth. This and export as rendered curves and areas are probably the most popular option selections. And then fourth, we have the pretty self-explanatory don't export text objects, which will export none of your text objects. And for now, I'm going to choose to export as labels. The second option is for marker objects, such as these maximum peak and minimum depression symbols here. Again, we have 4 options to choose from. And first we have export as Placemark Pins. This is pretty similar to the text option. If you choose this, all symbols are exported as that yellow Placemark Pin, which is going to be that yellow push pin in Google Earth. You can go ahead and change the icon in Google Earth to another icon individually. And if you have many points, you may not want to choose this option as you could end up having thousands of little yellow push pins all over your map. Second, we have export as rendered curves and areas. This option converts the symbols to polylines and polygons. The marker symbols in Google Earth look just like they do in Surfer. So for example, if you had a star-shaped symbol in Surfer, it's going to look star-shaped in Google Earth as well. In addition, choosing this option means that the symbols will retain their relative size. Third, we have export as icon pictographs in the GIF format. This is a great option to preserve the look of the symbols while keeping the file size small. It exports each unique symbol as a small GIF file, and then that image is used as the icon when the file is opened in Google Earth. This is a great option when exporting classed post maps, or if you have multiple symbol types displayed on the map. Note that if you share the KML KMZ file with a colleague, you need to be sure you also send the GIF files as well. Otherwise, Google Earth is going to use the default options instead of what you had in Surfer. And fourth, we have the self-explanatory, don't export any of your marker symbols at all. I'm going to go ahead and leave this as export as icon pictographs. Third, we have Polygon Objects. This is going to be polygons that are drawn on the map or included in base layers. This also, again, we're going to have 4 options to choose from. The first 3 options all are going to affect the transparency or opacity of the map. And then the last option will be not to export any of your polygon areas. And for now, I'm going to choose to export using the application transparency so that our map looks as similar as possible as it did in Surfer and Google Earth. Then the next option is for Polyline objects. That's going to be polylines that are drawn on the map or included in base layers, such as contour lines and watershed or viewshed boundaries. There are only 3 options to choose from, and similar to polygons, they all deal with opacity or not exporting them. And I'm going to keep it the same as polygons and export using application transparency. The next set of options is for the line width. When the line width is set to fixed width for all lines in KML pixels, that means the line width is going to be the same across all lines when you open it up in Google Earth, even if you had individually set contour line widths in Surfer. The default option is scaled width in inches per KML pixel. This is where the line width for each line is individually determined, and you enter the number of inches per pixel here. The line width that is specified in Surfer in inches is then divided by the number of inches per pixel that you enter here in this box. And that will then determine how many pixels that line should be in the KML or KMZ file. This is best if you have a contour map with different line widths that you want to be displayed when you bring it over to Google Earth. I'm going to go ahead and leave ours as scaled. The next option is to split compound polygons into pieces. This option should only be checked if you're experiencing problems where some polygons aren't filled in Google Earth where they should be. We're not currently experiencing that, so I'm going to go ahead and leave it unchecked. And then the last option is to use the Z level of contour lines for the line object ID in the KML or KMZ file. This is useful if you are exporting a contour layer to identify individual contour lines in Google Earth and view the Z values for those lines. I would always leave that option checked. And now that we have covered all our options and I'm happy with our choices, I can go ahead and press OK to create our KML. And now that we've saved that as a KML, I can open back up Google Earth. And all I have to do is click File, Open, choose our Crater Lake PD KML file, and Google Earth will fly us directly over to Crater Lake, Oregon. And it has also added our peaks and depressions map. Like I mentioned earlier, we can press R to get a nice overhead view of this map. And you can see that after we've brought it into here, the transparency is relatively the same as how it was in Surfer for our opacity. And our symbols, the red triangle and blue circle, exported the same as they were in Surfer. They are not yellow push pins. And also, since we chose export as labels, if I zoom in and out, you can see that the text size changes as I zoom in and out. For the sake of parity, I also created a second version of the same map where I changed some of the KMZ export options at the end so everyone can see how your map can change. Go ahead and click File, Open, and open up that second Peaks and Depressions map. And when you're working with multiple KMLs in Google Earth, they'll be stored over here in the Places window, and you can show or hide whichever one you want to work with at that time. So I'm going to hide our original one and get this one into view. You can see for the second map, I used the Placemark Pins for text objects, and I set a transparency of 50%. So we have these yellow push pins instead of our original symbols, and the opacity is just a little bit different. If I want to go ahead and change one of these yellow push pins, like for our minimum depression area, I could right-click directly on the pin, go to Properties, then click on the yellow push pin symbol over here, and choose a new one that I think better fits it, like maybe this anchor. Press OK. And I personally, though, prefer our original map that we brought in. So I'm going to go ahead and leave that for our final product. The text is a little bit difficult to see, though. So if I wanted to, I could actually press the drop-down menu over here in the Places window, select our text, right-click that, go to Properties, Style and Color, and then I could choose something that maybe stands out better against this green mountainous area. I don't know, maybe pink. Press OK, and now you can see we've updated our text color there. All right. And that is going to conclude my presentation on creating dynamic maps in Google Earth and Surfer. Thank you again to everybody who joined us today. I really appreciate it, and I hope you guys have a great rest of your day.